Hey everybody, welcome to another weekly live stream here with the NVIDIA developer team. I'm really excited about this one because after we've done our recent videos on the DGX Spark, the community just continues to tell us their questions, share their interests, share their curiosities. And so we're glad that we get to do this again. As always, for those of you that are watching from around the world, make sure in the chat you can tell us where you're joining from and add your questions. What are you wanting to know about the Spark? Because we've got some of the right people joining us today to be able to answer all of your questions with one of the biggest burning topics that we've seen from the community, which is how do we use more than one Spark and why would we use more than one Spark? So joining us today, we've got some folks behind the scenes. We've got Weiwu, Manolis, Papadakis, and of course our producer, Zach Lowe, that's pushing all of the buttons to bring things on screen. We've also got Alan backstage there. And then joining me front and center on the camera today, give a wave to the audience there, Mr. Bo Dong. Good to see you, man. Thanks for joining us.
Yeah, thanks for taking me. It's my pleasure to present the story here.
Yeah. I'm so glad that we've got folks joining in. I can see in the chat, we've got folks from Maryland, Florida, Brazil. Someone just joined from Uganda, someone from the Netherlands. So I think a lot of people are staying up past their bedtime to hear your perspective on the Spark here, Bo. India, let's see, Greece, Texas, man, Kenya. Wow, we got a quite the international audience today. This is really cool. Arizona, nice. All right, well, I think we're going to be talking about all kinds of things related to not just the Spark, but running cuPyNumeric, these multi-GPU instances and more. So we've heard from the audience before that they love when we can just dive right in. So, Bo, what is it that you want to show us today in response to some of the community feedback and questions?
Yeah, sure. So for today, I'll just show running cuPyNumeric on stack DGX Sparks. I'll show the hardware and also do a quick video demo of it running, scaling from one node to another node.
Mm-hmm.
And the simple itself will be really not that interesting. It's just matrix multiplication, except the size is pretty big. We'll go to a like 40K by 40K matrix multiplication and showcase the power of DGX Sparks and two of them.
Awesome. That sounds great. And, I don't want to ding matrix multipliers. They're foundational. So, I think that's still a valid demo for everybody. And in case anyone's wondering, we've been doing the DGX Spark live stream as a series. We're going to do this every week. So you can check past episodes on our YouTube channel or on our social channels. And we're going to have more coming from there. So, Bo, where would you like to dive in first? And we can have Zach bring anything up that you like.
Yeah, let's do some quick intro, and we can go to the next slide. Just say, hey, why we come here? So, accelerated computing that powers all science here, not only AI. We're doing simulation, data processing, all those things are running. And if we go to the next, we'll see there's more and more supercomputers with powerful GPUs go live online. That makes the scientific community have more access to the accelerated computing scale. And the question is like, why people need to scale the thing for more than one GPUs? GPU itself is very powerful already. Why people need more? To move to the next slide, we'll see actually for different kind of use cases, there are reasons why people would need more power here, including one, if you are running a problem that is bigger than a single GPU, you cannot fit that in. How you handle that? If you can get more than one GPUs or get multiple GPUs, then you will scale the problem out, right? Sometimes people are looking at weak scaling, how much efficiency I get when I'm adding more hardware and I solving bigger problem at the same speed. Another reason is about trying to get the things done faster, right? The same problem size, but you have to finish it with a short period of time. For example, if you do a weather forecast, it makes no sense for you to finish the computation in 2 days just for tomorrow. So that is sometimes people call about like strong scaling. Same problem, adding more GPUs to it, and people will see if they double the GPU, they'll reduce the time to complete the problem to half. So that's a reason why people would need more GPUs to solve their day-to-day problems. And if you move to the next slide, right? People say, hey, scientists, they have the supercomputers. What about me? I don't have access or whatever the DOE super clusters or something. And now, like you see, I have this thing on my desktop. It's a privilege that I got it like 1 month ago. You see, I put them stacked. And just to explain a little bit, you see the black cable. That is a DAC cable connect back to back of these two devices, providing a 200 gig like bandwidth for this connection. This is a private network. I just configure the network between these two. And the blue cable here, actually, that is a cable connect to the company network. That allows not only me, but my colleagues, they can SSH into this cluster and start running things in this 2-node cluster, right? People can use 1 node or 2 node, depending on the problem or the time they want to get the problem to be solved.
Yeah, I think that's an important detail, because I was talking to one of our seed partners earlier, and I think there's still some confusion in the community about this idea that a Spark is for me as an individual developer or engineer. But the reality is we're starting to see use cases pop up where there maybe is someone that owns the Spark, but they can actually leverage the Spark when they're collaborating with others. Maybe they have it locally at their desk or in their lab, but other people are able to SSH in. And you can even bring this into a hybrid environment as well, where if you've got applications people could access through a domain or something like a Cloudflare. But I guess the key takeaway here is it's not just isolated to you, right? It's something that you can leverage when you're trying to do research with others. To your point, if people are actually pulling data for some sort of weather report or some sort of analysis, you don't want to actually have to wait to take turns accessing this machine. And that's one of the things that the Spark enables.
Cool. Yep. So if we move to the next slide, and we'll do a quick demo. Again, the reason why I do a video demo is this is a shared environment. I don't want someone else is using that and make the demo being paused. Okay, if we make a pause here, let me do a quick intro about what we are seeing here on the screen. On the screen, we have 3 consoles. On the left-hand side, that is a console I will do most of the command and running things. And on the right-hand side, you will see there are 2 consoles on top and bottom. The top one, I believe, is the head node for the DGX Sparks. That is the one at the bottom. The temperature is higher. And the second one, the lower one, is the other DGX Sparks. And here what we are using is NV-top that shows the GPU utilization and some of the other metrics indicating how things are running. If we move the screen up, do you want to add something, Alan?
No, please.
Yeah, if we move it forward, let me show you the code where we're going to run. If we make a pause here, you can see this is a very like simple Python code. Looks familiar, right? It's similar to a native Python and NumPy code. And what it does here is doing a 40K by 40K matrix multiplication. And I have no code special for distributed computing, no MPI. I'm not managing partition. It's just a stream code. Then I will run it on the DGX Sparks. If we move forward, starting from running it on a single node. So I will use this command line to run it. If you see the node 1, I indicate I'm going to run it on 1 node here. And we see on the right-hand side, the top screen, the NV-top, shows the GPU start kicking in and do the computation. Okay.
So seeing in the top panel, yep.
Yep. So if you pause here, basically it's a computation that finished the 40K by 40K matrix multiplication in around 9 seconds. And let's try to do it on the 2 nodes. So what I need to do is I don't have to change any of the code. I just change the command line option, make it a 2. And once we run it, now we see both of the nodes kick in to start do the computation. Now this computation finished like around 5 seconds. Not too bad, right?
Yeah. You can see the speed up here.
Yeah. So basically, this is the demo. Quite simple. Just to demonstrate some computations happens on one node, on two nodes. Yeah, I know people have question of how to make it run in your environment, especially how to make it run on a single node. If we move to the next slide.
Yep. Let's go back to the slides.
Next one. Yes. Oh, previous one. So we have a tutorial hosting online that is the cuPyNumeric, and the tutorial itself covers how to run it in a single node with single GPU, multi-GPU, and also cover some of the node to some DOE clusters, supercomputers, how to use that. My colleague Wei and Manos also working on the playbook that document all the how-tos making this cuPyNumeric running on this stack DGX Spark. We'll publish it and share the link shortly. Maybe not today.
That's okay. Well, there's always updates coming from NVIDIA, and there's always new resources that are showing up. So make sure you guys stay in touch and follow our tech blog, follow us on social channels, and that's where you'll get updates, and also communicate with us on our forums and on our various Discord servers. I think it was interesting, the simplicity that you showed there, Bo, going from one node to two nodes. Can you talk a little bit about that with how is that enabled inside of the DGX Spark? Like, I think right now with what we're shipping so that we support up to 2 Sparks. So what is sort of happening behind the scenes there?
Okay. Yeah, sure. So if we can, so what we are doing here is people see cuPyNumeric, that is the multi-node, multi-GPU library we built. The team has been working on it for several years. And it's not only a library, actually, it has a runtime underneath. And in fact, Zach, if you can help to go to the slide, I believe I have one in the backup about the stack. Move down there, a couple slides down. Yes. So what we have is this is called Legate Legion Realm. This is actually a runtime came from Stanford. They are building a task-based supercomputing framework. And on top of that, like cuPyNumeric that implements NumPy and also some of the SciPy functionalities, include the SciPy Sparse, and then other things is like XGBoost for traditional AI, and Polars on Legate data frame that give the data frame functionality. And everything here is designed to do the thing like I showed just now. It's implicit parallelism for multi-node, multi-GPU. And yeah, that is how it works. And I don't know if we want to go to the detail of how it's inside. If we move down, so what the secret sauce of it of Legate is, one more slide down, if that's fine. Actually, the runtime, I see the secret sauce has 2 parts. One part is on the left-hand side, we do the runtime itself take the sequential program from the developer or from the researcher and do analysis at the runtime to see, hey, how we can partition the problem and what the parallelism exists in this computation. And after that, it dispatch to the underlying infrastructure so that it can run in parallel. And to do a distributed computing, it's not only like tasks, but also how the data are managed, right? The data need to send to the place where it should run, and after it's computed, it should be collected and get a result. And Legate also has the functionality of managing the data, doing the partitioning implicitly again, and then to send the data to do the communication to get it running in this distributed environment. I hope that helps.
No, that's super helpful. And I think, these are I love that you called it the secret sauce, because I think these are a lot of the things that people don't realize happens in the development of the back end of where we're trying to reduce that complexity for the developers so they can focus more on the research and the results of what they're doing. I know we have a number of questions that have come in, and I appreciate that someone actually was asking, hey, isn't there an issue when you stack them top to bottom like this with cooling? When they get hot together, obviously we wouldn't release a product if there was an issue with stacking them in that way. And in your photo, you've been using the device. So have you had any issues at all?
No, so I have been using it for more than a month, and also like we even demoed in GTCDC all day year running. Not a problem as far as I see.
Yeah, that's amazing. Someone was jokingly saying, well, it must be coated with lava rocks. No, it's just really, really well designed and engineered. So no issues there. Well, let's dive into some of the questions, because we've actually got quite a few today. And again, wherever you're joining us from in the world, make sure you say hi in the chat. So it looks like Zach brought up one of the questions, but I think we just did this, which is, during the presentation, can you discuss running cuPyNumeric locally with only one Spark available? And that's really what you're getting down to today, right, Bo?
Sorry, can you repeat the question?
Yeah, so they were saying, just can we discuss what it's like running cuPyNumeric locally using only one Spark? And I guess let's rephrase this a little bit. For you, how does this compare to non-Spark environments? Like, what is the advantage that you're getting here?
So for the non-Spark, so cuPyNumeric can run in multiple environments. Like you can even run it in your laptop, even if it's a Mac laptop. It can run with CPUs or GPUs, and it can run on the like DGX SuperPod or supercomputer. They can run all these places, and the code will be the same, just like this simple code, like NumPy thing. And when you run, if you run one node, actually that is, you just use Python, then that will just work. Or you can use Legate as a command line to kickstart.
Right.
And in the multi-node, we need a initializer for it. So for supercomputers, people often use MPI run or Slurm. cuPyNumeric and Legate will work with all of them. And actually in this setup, I configured using OpenMPI as to initialize the process in these two DGX Sparks. So come back to the question about running in DGX Sparks. I don't see it's quite different as I running on my workstation or my desktop or my laptop. It's just quite straightforward, and only is it comes with the GPU that is pretty powerful with many memories that I can use so that I can run bigger program.
Yeah, and I think one thing worth noting, there's a couple of comments that I've seen online, but the one thing that's worth noting is, if you were collaborating with a team, or even in your own workloads where you're running some sort of batch, if you were running that on your laptop, you more or less have bricked your laptop until it's done running its operation, right? If you were using one of those devices. But by having the Spark, you can continue doing your work on your workstation while you're actually pushing that compute over to the Spark. And then you have other team members that can also access that Spark in real time. So I think the best way for people to think about this is the scalability solution that it actually offers you when you're developing. And I saw some people talking online about how the advantage of this is you are getting access to a Grace Blackwell architecture. So you can start building your applications, tuning to these architectures for the GPUs, right? You can optimize from there. Let's see, we've got another one here. So this question came up, but I'm going to bring it up, Zach. I'll hit the button. It says, for those of us who ordered a single Spark, will there be an option available for us to order an additional Spark with the correct cabling to do clustering, since there's a limit of one per customer? I forget, what was Alan's response on this one? Bo, do you remember?
Oh, I don't actually. I'm doing the software. I'm not doing the hardware thing.
I'm going to bring Alan up. We're going to bring him out from backstage. Alan, what was our response on this one? You're on stage.
Yeah. So if you order a single Spark, it doesn't ship with the cable. If you order a dual Spark configuration, at least on our website, you would get the cable with it. You can order from our partners. We've got plenty of our partners selling online and in retail. And it's a standard QSFP cable. I know people like the one we have. It's a short little cable, but if you've got a QSFP cable around, it should work. But those shorter ones you should be able to get from our online partners and any of our retail partners.
Nice. Thank you for popping in, Alan. Appreciate you. Let's see here. What do we have as the next one? So I know we talked a little bit about DGX Spark scaling with cuPyNumeric across the multiple GPUs. Someone asked the question here, how do we do that without hitting communication bottlenecks?
Okay, what about let's bring up Manolas or Wei. They are my engineer colleagues.
Let's bring the gang in.
Yeah.
Okay. Yeah. So I guess two answers to that question. First is the fast interconnect, the little SFP cable that Bo showed. That that'll give you plenty of bandwidth for at least reduce the overhead of communication. And then of course it's it depends on the application as well and the size of data that you want to process. And of course, depends on the software that you're using and how well they've optimized for communication overlap. So, any of our LLM software packages would certainly be super optimized for the DGX platform. And for something like cuPyNumeric, where you're throwing more custom code at it, that also depends on the amount of computation versus communication that you would have and how much you can batch things together. Yep.
Wei, any other thoughts about the communication networking between the two devices?
No, I think Manales already answered most of the questions.
Okay, perfect. Someone was also asking, let's see, I think this is the same person, says, I have a question about the cabling. Which cable should we use? And could we use 2 for increased bandwidth between the 2 units, or is that not recommended effective? Yeah, I think we've covered most of that today in the stream, but we did have questions before of, is this the intention of being able to scale? And I think it absolutely is. We recognize that while you're developing and building on the DGX Spark, this is also a pathway towards larger systems and larger integration for architectures, right? But do you see the potential in being able to scale even beyond the 2 DGX Sparks? I guess I'll open that to the room to see if anybody has any thoughts.
Actually, I don't see from the experiment and my understanding of what cuPyNumeric does, I don't see there's an issue of us doing so. I even talk with the DGX Spark hardware and software team and say, hey, why cannot I go to like more than 2? They say, no, there's nothing limit you not doing that. It's just you need to get those connected. We even joke, say, hey, if we have like a switch and we hook in many of the DGX Sparks together, and say, well, that'd be very noisy in the office because those are getting those fans running for the switch. Yeah, I'll be more than happy to get some more DGX Sparks from you, Alan and Mark. So we'll make a try.
That's a consistent theme I'm hearing from people. They're like, I'd be happy to have more of them. Yeah, no question from there. Yeah, we've had a couple of people that have asked this question about scaling and what does it mean to be able to turn these into sort of micro clusters? I know some companies out there have done this with Mac Minis, and now they're starting to experiment with the DGX Sparks themselves. And it's a really interesting application for when you are needing to run locally in the field, being able to ruggedize these, being able to get these out into environments where you might not have access to data center types of infrastructure or a lab type of infrastructure. A lot of really interesting applications for people that are in emergency response environments and more. So I think we're going to hear a lot more about this scaling. Let's see. Someone said, which version of NVTop are you using? I saw in earlier version of NVTop, it wasn't able to display the GPU memory usage and said it was due to the GP10 ARM architecture. Is it true? Is anybody familiar with this question from the community? Cool avatar with the Darth Vader helmet there.
I'll ask Wei and Manos to help this time again.
I'm not aware. We'd need to check and get back to you what was used, or maybe Wei knows.
No idea about that. Yeah.
Yeah, nothing on this one. All right. Well, for those comments, we will follow up later and go back to that social channel. We've also got some questions. If you develop on a DGX Spark using AARCH ARC software, but later you want to deploy on DGX H100s, A100s, or B200s that are running on x86 64 architecture, what's the main difference here?
Manos, do you want to take this one?
Yeah. So the software stack, for the most part, is available. We make probably all of anything CUDA should be available on ARM as well as x86.
Mm-hmm.
So from that point of view, it would. There's no fundamental difference. I mean, you would, the software itself might have different performance characteristics on each of these different architectures, depending on things like the width of floating point that you use, and how well it's been optimized for one versus the other. So yeah, I would think part of the story for these DGX Sparks is that you can start working at this smaller level if need be, and then if you need to scale up, it should be a similar experience, so that I'm sure the experience will be a pleasant or straightforward. But yeah, I mean, it's a different architecture, it's a different version of the same package.
Mm-hmm.
So some differences I would expect, some difference in performance characteristics, but I'm sure our entire team has done a good job making the experience translate between the different architectures.
Yeah, compatibility should not be a major issue, right? Let's see. We've got a couple more questions that keep coming in. I'm going to jump on this one just because I've heard people mention it during our previous streams. Someone asked, when do you expect NVIDIA will allow for connecting 3 to 4 devices? Allow is an interesting word. Technically, you can do that, but right now we support 2 Sparks at a time, right? But there's nothing stopping you from pushing it further. It's just not officially in our docs as of right now. I suspect we'll have more about that in the future, though. Okay, so now someone's got a bit more of a technical one. Let's bring up this question from AI Ran, which says, how does cuPyNumeric manage internode communication overhead in small DGX clusters? Does it rely on NCCL-based collectives by default or include optimizations for NUMA topologies on workstations?
Wei or Manos?
Yeah, you want to take this?
Yeah.
Sure. So for a lot of our operations, it's nickel based. For things like sort, it will be based on nickel point-to-point communication, which doesn't make much of a difference if you only have 2, but goes differently. It's a different story. Collectives are point-to-point as you go up. Yes, for a lot of operations, it would use nickel. For other platforms and for certain transfers, even on GPUs, it would use UCX as the communication layer, and then UCX has optimized transports for NVLink and InfiniBand and even local node CUDA IPC. So yeah, generally speaking, either one of these technologies should be able to use any RDMA technology that the hardware supports.
Perfect. All right. Well, I guess the let's bring up the slide again real quick, Zach, so we can give people the QR code so that they've got the action of where they can go here, and because you can start building for this today. So let's see. You've got your slide through the stack there. Perfect. So just real quick, you know what's involved in this link that we're pointing people here to, Bo? Oh, you're muted. Let's unmute you.
Okay.
There you go.
The link and the barcode here is lead to a cuPyNumeric tutorial. Basically, that is a step-by-step from scratch how to install cuPyNumeric, and also in different environments, like we mentioned, except for DGX Spark cluster. We'll publish it later. And then also have several examples, including matrix multiplication and other scientific examples, more meaningful, like Black-Scholes or so on and so forth. And for you try to run the code, as well as explaining some of the distributed computing considerations of how to solve the problem in more than one node. So it's pretty straightforward to follow, and also it's pretty deep in terms of what it does behind the scene.
Awesome. Well, with that, I know we are at time. I want to thank everybody for joining us today, especially the NVIDIAns that joined us, because you're busy folks and it's really hard to get time away from your projects. So appreciate you guys joining us today for the community. And for those of you out there watching, you can always access this video on demand on our YouTube channel. You can reach out to us via all of our social channels. You can also join us on our forums if you have questions. And with that, we will be back again with more insights and reveals on the DGX Spark next week. So make sure you're checking our calendars and checking our channels for those updates. With that, thanks so much, everybody. Have a great rest of your Friday and weekend, and we will chat again soon. Bye.